So when should we use simulation? Well, we have to use that if that facilitates an in-depth analysis prior to making decisions and implementing the results in a real system. These remarks are from Michael Pitt, an academic from the UK, which is one of the gurus in simulation. And we can resort to simulation because mathematical models are not good enough. We saw the Acme case at the beginning, the bike company, and that is a very good approach in some cases, but in many others, that is not something which is a good option for us to address a problem. Sometimes the assumptions we have to make for us to create such a model are too strict, and eventually we end up with an oversimplified model that does not represent reality in sufficiently good terms. So the results of those models are not reliable, and we cannot implement what comes out of them. Sometimes what we have is a mathematical model which is nice, elegant, but you cannot solve it in reasonable time. You run that on a computer and you cannot get results to implement the solutions that you get from the model. This is what we call intractable. And sometimes there's just no way to build an exact model. So these problems before are not even an issue because we don't have a model to use. In those cases, simulation could be a good option for us to represent our model. And instead of experimenting with a real system, we can experiment with a simulation model, with a digital twin, which is a term coined kind of recently that refers to at least this kind of approach feels within that topic. So sometimes experimenting with the real system is very expensive. So we prefer to develop the model within our computer to get results out of that model and not to spend too much money. And sometimes it is just too slow or too fast. So imagine you're reproducing the behaviors of something in biology. For example, you might have the system to behave in a very fast way and you cannot observe what goes on. Sometimes it is just slow. Imagine you want to explore what happens in your supply chain for several years and you just implement something in the real world. You have to wait for years till you get results. That is something which makes no sense if you can reproduce that behavior in your computer and speed up the process and get results earlier on. Sometimes it is just dangerous. You want to change to check if some way of managing some vehicles in a imagine a railway station is something which you should do or not. If you make mistakes when devising the policies for managing these vehicles, that can be dangerous because it can lead to accidents, and that it would not be the case if you're using a simulation model. Sometimes it can be even illegal if you want to, I don't know, try some policy or something, or explore what might happen if a system behaves in some way, and to explore what you should do if that happened. That could be illegal to force the system to work that way, but you can explore what would happen within your system. And many times it's very often impossible to replicate it. For example, in the previous supply chain example, you can implement a solution regarding where you locate your depots, for example, but you cannot replicate that because once you've made a decision, you have to wait several years to see how it went, but you cannot go back in time. So if you have a model, you can explore different solutions and replicate different scenarios and see what is best for you.